Assalamualaikum, my name is Muhammad Amran bin Azhar and my other two teammates Muhammad Amran bin Muhammad Rizwan and Muhammad Iqbal Hafiz bin Rumaizi. We present the energy efficient in electrical motors. So the guidelines and requirement of energy efficient motor. So the universal standards of the International Electrotechnical Commission, or in short IEC, indicates the efficiency classes for electric motors. So there are total of 5 IEC efficient classes. The first one is IE1, the standard efficient class, IE2 high efficiency, IE3 premium efficiency, IE4 super premium efficiency, and lastly IE5 ultra premium efficiency. So for IE5 is still under development by IEC. This is the table for each class's requirements. So for the output, IE1, IE2 and IE3 use 0.75 kW to 355 kW. For IE4, the output is 2.2 kW to 230 kW. So for the protection technology, IE1, IE2 and IE3 use IP55, IP56, IP65 and IP66. For IE4, the protection technology is IP55, IP56 and IP65. The speed range for IE1 is 500 rpm to 3600 rpm. For IE2 is 1000 rpm to 3600 rpm, and for IE3 and IE4 is the 750 rpm to 3600 rpm. So IE1 use 2, 4, 6, 8, 10 and 12 poles. For IE2, they use 2, 4 and 6 poles, and IE3 and IE4 use 2, 4, 6 and 8 poles. For the insulation class, for all classes use class F. For temperature class, all classes use class B. And the RPM frequency, all classes use either 50 Hz or 60 Hz. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Iqbal Hafiz Permaizi. Now I'm going to present to you about methods to measure the efficiency of low voltage induction in machine. I found two methods to measure it. So the first one is motor efficiency testing standards. Okay, what is motor efficiency testing standards? So there are several different motor testing standards which prescribe specific procedures such as what test equipment may be used, what data are to be collected, and how loads are to be applied. So this is table 1 that shows motor testing standards that cover all parts of the world. So for the first one is IEE standard 112. The Institute of Electric and Electronic Engineering's IEE Standard 112 is the standard used for testing induction motors in the United States. For standard test method for efficiency, there is 4 methods. First method is method A, which is simple input-output. Second, method B, input-output with loss segregation or separation. Method C, back-to-back machine test with separation of losses. And method F, equivalent circuit calculation. So this is equation for direct method of the IEFF 122. B, standard estimates the efficiency. Okay, for the second one is IEC standard 60034-2. There is 3 types of IECs. First type is machine input-output measurement power. Second type, input-output measurement power in back-to-back. And the last type is machine measurement real losses. I found 5 different methods that are included in the standard, but for this slide, I will use 4 only. So for the first method is method of direct motor. Second one, method of deceleration. Third, method with power factor 0, and the last one is method back-to-back. Okay, this is the second method that we use, which is estimation efficiency on the job site. So estimation efficiency on the job site is 3 steps are used to estimate efficiency and load. First, use input power, line current or slip measurement to identify the load imposed on the motor. Second, obtain a motor part load efficiency value. And finally, obtain a modified load using the power measurement at the motor terminals and the part load efficiency value. That's all from me. Thank you, sir.
Assalamualaikum and hi. So I am Muhammad Amran. So now I am going to continue on efficiency. So efficiency, the definition of efficiency is ratio between the shaft output power and the electrical input power. So the general formula of motor efficiency is motor output power over per motor input power. So the ideal motor efficiency is about 75% of the rated load, and there are a few types of losses that will affect the overall efficiency, which are resistance losses, mechanical losses, and others. So there are several ways to improve the efficiency of electrical motor. First and foremost, cover motor with frame. So this is to provide mechanical protection to the winding and lessen the heat losses. Next is keep the surrounding of motor clean and make sure always there is no blockage at the motor. So this is to increase the cooling system performance and to extend the lifespan of the motor. Third is increase the mass of stator winding. So this is to reduce the electrical resistance. Furthermore, reduce the slip of motor. So high conductivity of rotor will reduce the losses. And finally, reduce the thickness of lamination, minimize the core losses and flux density. So now we are going to continue on cost savings. So about 202 billion kilowatt per hour of electricity consumption, which is equivalent to 10 euro billion per year of industry operation costs can be saved by switching to energy efficient motor driven system in Europe. So this is based on Europe statistic. So the advantages of the EEM is the energy efficient motor. So first, reduce the costs. Next, improve the process of products. And lastly, reduction of carbon dioxide emission to the environment. So this is the explanation of the energy cost saving. So the benefits of energy efficient motor are energy cost saving, non-energy saving, reduce environmental costs. So for energy cost saving, the beneficiary is the industry, and annual benefit in euro billion will equivalent to 10 billion of 10 euro billion. So for non-energy saving, and also the beneficiary is the industry, so the annual benefit is around 5 to 10 euro billion, And lastly, reduce environmental costs. So the beneficiary is society, and the annual benefit is around €6 billion. Now we proceed with payback periods. So payback periods we define as two. Firstly is definition for replacement broken motor, and second definition for replacement of operational motor. So we see first let we see the first definition, which is for replacement broken motor. So the definition is ratio of difference between the price minimum and utility rebate to the value of the annual electrical savings. So this is the general formula. Price minimum, we will find the difference between price minimum and utility rebate per with total annual costs savings. So as for replacement of operational motor, the definition is ratio of the full cost of purchasing and installing a new energy efficient motor relative to the annual electrical savings. So the general formula, new motor cost, we add with the installation charges minus, and we find the difference to the utility rebate and per total annual cost savings. So this is more on the case that we find in real industry regarding replacing existing motor with smaller energy efficient motor. So an old standard motor, which is categorized as EFF3, this is EFF3, of size of 90 kilowatt and speed of 3000 rotation per meter RPM, is going to be replaced by an energy efficient motor of size of 75 kilowatt and the same speed. So we can see the difference of efficiency between the first and the second one, but produce the same speed, and they operate at 75% of load. So for EFE3 and EFF1, so the efficiency EFF1 is 94.8, which is higher than EFF3, and the energy used kilowatt per hour based on year, and we can see EFF1 is much lower than EFF3, where we can see about 300,000 compared to the EFF3, which is about 400,000. And the energy cost per year, this statistic is based on 1 year. So energy cost same. Also we can see that EFF1 is much lower than the EFF3. Same goes for the demand charge. EFF1 is lower than EFF3. So the energy saving, so we can see this is the energy saving. So we just minus the EFF1 value with the EFF3. So as for this, there will no saving because EFF3 is much more higher than EFF1 in terms of energy use, energy cost, demand charge. So there will not be any saving. So we can see the energy saving is about 80,000 and demand is about 13.9. Energy saving is about 4,000 and demand savings is about 800, and total saving that we could get from EFF1 is about 5,000 compared to EFF3. There's no any saving in terms of energy cost and so on. So the simple payback, as we know, the lower the payback, the better the attractive it will be. So you can see this has a lower 0.81 payback, so it is much more attractive compared to EFF3. So that's all from me. Thank you.